Hello and welcome to a new video. This is for Algebra 1 and we're starting something new. This is going to be the beginning of Unit 4, Linear Inequalities. This is Lesson 1. So we're going to introduce the idea of linear inequalities, try to understand what that phrase even means, and we're also going to talk about how to graph linear inequalities. With a warm-up, we're going to warm up and just solve a normal old equation, get our equation rules fresh in our minds. So 2x minus 4 equals 12. We have these properties of equality we can use to solve equations so that we don't have to try to figure this out in our head. And so the way this works would be we try to move the 2 and the negative 4, and the order we do that in matters. If I try to move the 2 first, I'd have to divide everything by 2, which is not the worst thing in the world on this problem. But because it's easy to forget to divide everything by 2, I always try to save what's right next to x for last. So I'm going to move this minus 4 over to the other side by adding it. So what we do is we say plus 4 and plus 4, and negative 4 plus 4 is 0, so that goes away. It leaves me with 2x on the left side, but I have to add the 4 to the 12 in order for this to still be equal. So 12 plus 4 is 16, and then my last step now is to divide by this 2 in front. So divide by 2, divide by 2, x equals 8. Okay, that's really what we've been doing so far. There's 4 different inequality symbols that we have to pay attention to, what they are, what they mean, that sort of thing. We've got less than, which looks kind of like an arrow pointing to the left without the line part of the arrow. We've got less than or equal to, which looks like a less than symbol but with a line underneath. You are supposed to think, whenever you see the line underneath, of basically combining a less than symbol with an equal sign. So if that helps you to remember that that added line is equal to, then that would be great. Then we've got greater than, and then we've got greater than or equal to. So greater than kind of looks like the arrowhead pointing to the right. Greater than or equal to looks the same but with the line underneath, which is supposed to make us think of an equal sign. So this is, I've got some examples here with numbers of what this situation kind of is implying. Like a less than symbol, we'd have something like 3 is less than 5, which is true, right? Because the number 3 is smaller than the number 5. When we do less than or equal to, we're adding something to our idea of less than. We're saying, yeah, our number could be smaller than 7, but it also could be equal to 7. Okay, so these examples are not like the only thing we could come up with. Literally, I could have put any number that was less than or equal to 7, and it would be true, including negative numbers or 0 or things like that. For greater than, the bigger number should be on the left. So 10 is greater than 3 is a true statement because the bigger number is on the left. Greater than or equal to has the same situation as less than or equal to, where we could be talking about something that is actually greater than what's on the right, or we could be talking about something that's equal to what's on the right. Okay, so that's a general overview of our inequality symbols. Now let's think about what adding a variable into this means, because we're in algebra. So our ideas here are basically to take everything we've done before with numbers and add variables into the mix. So what would the following inequality mean? X is less than 5. And how can we represent this idea? So think about it. If I said, I don't know what the number is, but I know it's less than 5, what numbers should spring to mind to you? Should it be numbers like 4, 3, 2, 1, and so on? Or should it be numbers like 6, 7, 8, 9, and 10? Which of those sets of numbers is less than 5? And should I include 5 in my answer, or should I say that 5 is not an option? So here's how we can represent something like x is less than 5. We are going to use a number line, and we're going to graph our inequality answers. So there's kind of 2 ways to write inequalities or to show inequalities. One is to have it solved where x is by itself, just like we do with equations. And then we add to that this idea that, you know, maybe it's helpful to have this represented on a number line. So if I want to represent x is less than 5 on a number line, there's 2 things I think about. 1 is whether or not it's equal to or not, and 2 is which direction is our answer. Are we saying when we say x is less than 5, are we saying, like I already mentioned, are we saying that our answers should be things like 4, 3, 2, 1, or that they should be things like 6, 7, 8, 9, 10? So the first part of that, is it okay for 5 to fill in this variable? Can I say 5 is less than 5? No. Okay, so what we do to represent that on our number line is we make a circle at 5, but we leave it open. So this is an open circle at 5. Now, if it was equal to, what we do is we would color in our circle. So this would mean that we were equal to at whatever our point is, but the open circle means we're not equal to. And here's why that's important. So I was talking about, our answers could be 4, 3, 2, 1, or 6, 7, 8, 9. Which of those makes sense? Hopefully you realize 4, 3, 2, 1, and so on are the numbers that are less than 5. So what we do is we shade on our number line the direction of the numbers that work. So that would be to the left. And we put an arrow at the end to show it goes on forever. So this is a graph of the inequality x is less than 5. But the reason the open circle matters is because we're actually trying to show that it's 5 that's the place where we stop having answers. So if you were thinking, oh, well, couldn't I just put a filled in circle at 4 and say that that's my answer? So maybe you're thinking I should put a closed in circle at 4 because 4 is less than 5, and then I can go to the left, right? Well, that actually leaves out some important numbers here that could be a part of our answer. Yes, we like whole number answers, but if I have x is less than 5, 4.9 fits into that inequality, I mean. 4.9 is less than 5. And so is 4.99 and 4.999 and so on. So the open circle is there to show us where we stop having right answers, which is at 5 exactly. Anything that's smaller than 5, even if it's just a little bitty bit smaller, is still going to end up being a part of our solution. It's kind of a weird idea at first, but I think it's one that you can get the hang of. Or just remember, when you have not equal to, so no line underneath, we put an open circle. When you have equal to, we're going to put a filled in circle. So let's try this. Let's graph some inequalities. So the variable here does not matter, as in they can use whatever letter they want, and we can still use the same number line. So we will see x's a lot, but we could see any letter, and that's fine. We're going to graph these inequalities. There's no solving involved here because our variable is already by itself, and even better, it's on the left side of our inequality symbol. We're going to see a little bit later that makes things easier. So A, x is less than or equal to 3. So my process going through this is going to be to say, okay, is it equal to, which I look at the line underneath to see. So yes, this is equal to. Okay, so that means I'm going to put a filled in circle at 3. Because 3 is the number I know something about here, right? Because it's in the inequality. I'm going to put a filled in circle here at 3, and then I'm going to think, okay, which direction do I shade when it's less than? There's a really cool trick, actually, that, like I mentioned before with our less than and greater than symbols, they kind of look like arrows. So what's really cool is if your variable's on the left and your number's on the right, and you have an inequality, it actually is pointing the direction that you should shade. So if I think x is less than or equal to 3, what numbers apply to that? That'd be like 2, 1, 0, all the negative numbers. Those are all to the left. And that's the way this is pointing, right? If I pretend like this is an arrow, it's pointing to the left. So that's really cool and really convenient. I'm going to show you a few different ways that you might shade this to help your teacher out with seeing it. So I'm using a different color than black because my number line is black. It'd be hard to see a dark color or a similar dark color on a similar dark color, right? So one way is to use preferably an erasable colored pen or a colored pencil that you can erase in case you mess up, but that'd be one way to do it. Let's look down here at b. Y is greater than -2. Okay, so are we equal to or not equal to? There's no line underneath, so we're not equal to. So this is going to be a open circle at -2, which is right here. Then I look at my inequality and say, okay, what numbers fit this? If y is greater than -2, am I talking about the numbers to the left of -2 or the numbers to the right of -2? Well, the other way to do it, by the way, is to actually pick a number. 0 can be nice to pick unless 0 is involved. Is it true that 0 is greater than -2? Yes, that's true. So we want to shade the same direction that 0 is. So we want to shade this way over here. And then we put an arrow at the end. I was going to show you a different way of shading this that made it look different, and I forgot to. So I'll do that hopefully on the next one. A is less than 4. So I think, is this equal to or not equal to? It's not equal to. So we're going to put an open circle at 4. So here's another way you can do this to make it look more obvious. You actually, instead of shading on the line, can go up and above like this. And then it makes it more obvious that that's the direction you shade. Basically, if you look at your work after 5 or 10 minutes or something like that, after you've done it, and you can't tell which direction you shaded, like pretty quickly, like if you're having to look super closely to tell which direction you shaded, you need to rethink your shading strategy, because your teacher is basically going to be like, yeah, I can't tell which way you shaded. So you can make it thicker on the line or a different color on the line, or you can just make it go above or below the line like what I've got here, and that should help your teacher see. This last one, D. If you got the hang of this, try this ahead of me, right? So n is greater than or equal to 7, so I think, okay, it is equal to, so I'm going to put a filled in circle at 7. And then it's greater than, so I think, okay, what numbers are greater than or equal to 7? Is it numbers like 6 or is it numbers like 8? We can really just think right next to the number and say, okay, which one of these situations is greater? Is it that 6 is greater than or equal to 7, or is it that 8 is greater than or equal to 7? Well, 8's greater than or equal to 7, so I'm going to shade to the right. Okay, so that's just an overview of how to graph inequalities, and that may even be, or hopefully even, with something that you did in pre-algebra. But now let's add to that this idea of solving inequalities. So can we solve this inequality that I've written, 2x is less than 10, in the same way that we solve equations? And what does it even mean to say 2x is less than 10, by the way? So if this was an equal sign, and we had 2x equals 10, we'd divide both sides by 2. And we'd get that x equals 5. So what connection can we make to our inequality now that we know that if it was an equal sign, it'd be x equals 5? Well, let's think about what numbers would work to fill this in. This is saying 2 times something is less than 10. Does 5 work? If I do 2 times 5 is less than 10, does that work? Well, no, but only because it's not equal to, right? So we're not equal to at 5. Well, let's think about some other numbers. Like, would it work to use 4? If I do 2 times 4, is that less than 10? Well, yeah, I'd get 8 is less than 10. What about the other direction? What if I do something like 6? Is that true? 2 times 6 is less than 10? That'd be 12 is less than 10. So that doesn't work. So I'm getting the feeling that our answers to this are anything that's less than 5. We can solve this the same way we solve equations, by dividing both sides by 2. And we get x is less than 5. So they're basically, if we're solving an inequality, there's kind of 2 things we could be asked to do. We're asked to solve it, so we have an inequality answer that x is less than 5. But we also maybe are asked to graph it, and so we would go ahead and graph it on the number line. So if you see instructions that say solve and graph, you really have 2 answers going on there. The solution written out as an inequality, and then the solution graphed on a number line. So which direction is x is less than 5? That'd be to the left, because we said numbers like 4 and whatnot. So to the left, to the left. So let's try kind of one step linear inequalities and see how this goes. So remember back to your equation rules, apply those equation rules, and then we're going to graph our answers. So if I have x plus 5 is greater than 3, if it was an equal sign, right, I would subtract the 5 over. So let's do that. Minus 5, minus 5. So x, we're going to keep the greater than symbol. And 3 minus 5 is a negative number, and it's negative 2. So part of my answer is that x is greater than negative 2. And then I'm going to put an open circle here. And I'm going to think, okay, which direction are the numbers that are greater than negative 2? That would be the numbers to the right. Like 0 is greater than negative 2. I'm going to shade this way. All right, let's look at these next ones. So m minus 7 is less than negative 2. How do I solve that if it's an equation? I add the 7 to both sides. Plus 7 and plus 7 gives us m is less than negative 2 plus 7. Well, those are different signs, so I subtract, right? 7 minus 2. Oh, wait, that's easy. 7 minus 2 is a positive 5. So m is less than 5 is part of my answer, and then I put, okay, is it open or filled in? So I put an open circle at 5 because we're not equal to, and then I think, okay, which direction am I going to shade this? The numbers less than 5 are to the left, so this way. Let's look at C. 2y is less than or equal to 8. So when we were solving equations, the way we did this is we divide both sides by 2. So y is less than or equal to 4. And at any point along the way here, if we're not sure that this is really working for us, we can think about plugging the numbers back in to see if it works. So if I plug in 4, is this a true statement? 8 is less than or equal to 8. Yeah. If I plug in a number that's smaller than 4, like 3, is this a true statement? 6 is less than or equal to 8. Yes. So don't forget that you can actually check to see that what you're writing makes sense. We forget that a lot, I think, in algebra, that like these things are actually supposed to make sense, whatever you think about them. So I'm going to put a filled in circle at 4 because it's equal to, and then I'm going to shade to the left. All right. D, c over 3 is greater than or equal to 1. Now this is probably one that is trickier just because every time we see this fraction, we have to remember how to solve it. I think that's tricky. So we're saying c divided by 3 is greater than or equal to 1. So the opposite of dividing by 3 is to multiply by 3. So this is c is greater than or equal to 3. Does that make sense? If I put 3 in, 3 divided by 3 is greater than or equal to 1. Is that a true statement? That's 1 is greater than or equal to 1? Yes, that's true. If I pick numbers that are bigger than 3, now that's where it gets tricky because these are fractions. So if you pick 4, is 4/3 greater than or equal to 1? Well, yes, but you may not like thinking about that because it's a fraction. So 6 over 3 is 2. Is that greater than or equal to 1? Yeah, so I think I feel pretty confident that c is greater than or equal to 3 is our answer here. So let's put our filled in circle at 3, and then let's shade to the numbers that are bigger than 3, which are to the right. Put our arrow, and voila. There are a couple things that make inequalities trickier than an equal sign would be. So when we have equal signs, saying x equals 5 and 5 equals x is the same thing. That's actually a property. The property that says that those are the same is called the symmetric property, because we can think of this as having symmetry, that it's like a reflection thing happening. But it's not going to work exactly the same. I actually just realized, I guess it is kind of the same. If I reflect this over, so I put x here and I put 5 here, it actually kind of makes sense what we need to do, which is we need to turn the inequality around, right? Because if you're looking in a mirror here, and you have 5 is less than x on one side of your mirror, and then you flip it, well, x is still going to be closest to the mirror, 5 is going to be farthest away, but the inequality symbol, like, in order for us to actually have a reflection, they should be going opposite ways. So this is a thing that is helpful because if x is on the left side, then our inequality is pointing the direction we want to shade. So you don't have to flip it around if you don't want to, but I strongly encourage you to flip it around and have the x be on the left because I just think it's easier to graph. If you look at 5 is less than x and you're like, oh yeah, I can understand that that means to shade to the right, well, you know what? That's great. That's not my best circle. But I really think it's a lot easier to flip it around and say, okay, this means I'm shading to the right. I'm shading the things that are bigger than 5. So it's kind of up to you, but do watch out for that. That's one of the things that can be tricky about inequalities. The next thing that's tricky about inequalities is that there is an interaction with negative numbers that happens that is not an issue with equations, but is an issue here. Let's think about what numbers work for this, okay? So if you put in, let's start easy, let's do 0. If I put in 0, is this a true statement? -2 times 0 is less than 10. Yeah. How about, you know, a negative number like -2? If I do -2 times -2, I get +4. +4 is less than 10. Okay, that's true. What other numbers could we try here? Like, what about +2? -2 times +2 is less than 10. Is that true? That's -4 is less than 10. That's true. So all we've gotten so far is true. What are we going to have to do to actually get something that's not true? Maybe we need to pick a big number. Let's pick something big like 10 to see. Is this true? -2 times 10 is less than 10. Well, that's -20 is less than 10. So yeah, that works. So wait, if that big number, relatively speaking, didn't work, what should we try now? Should we maybe try -10 and see what happens? It's the point I'm making here is that negatives kind of change our game a little bit. If I put in -10, what happens? Well, wait, -2 times -10 is +20, and +20 is not less than 10. So here's what we here's kind of the rule that we apply to this. We're going to divide both sides by -2 just like we would in an equation. And we get x and something -5. But is it that we're saying that x needs to be less than -5? Or do we actually want x to be greater than -5? Look at the numbers that worked for us. 0 worked, which is greater than -5. -2 worked, which is greater than -5. +2 worked. +10 worked. Those are numbers that are greater than -5. What didn't work for us was -10. That gave us something that was not greater. So what that means is if you just drop this down and say less than, you haven't taken that negative that we divided by into account. We actually need to flip our inequality around. So this would change to x is greater than -5. This is really the tricky part, I think, of inequalities, at least at first. No, it's a continually tricky thing. Like, you're going to be sitting one day 3 or 4 years down the road and probably be like, oh, I forgot to flip the inequality symbol because I divided by a negative. But this is a rule that we can actually rely on, that this will be true. And in fact, here is our rule actually written out. If you multiply or divide by a negative number to solve an inequality, you must flip the inequality symbol. Now here's our first introduction to realizing that the method we use to solve something is kind of flawed, because we as a human being have to go, okay, I know that this is a rule that's there that I need to pay attention to, right? So if you're just doing your homework on autopilot, it maybe isn't going to work out super well for you because you might forget about this special rule. Okay, so it's that as you're solving, if you have to do something, you're not that it's in the equation itself necessarily, but you're choosing by solving the equation to multiply or divide by a negative number, that makes you have to flip the inequality symbol around. Okay, this would be 2 examples of situations where this would happen. On the first one, I'd divide by -3 to move it, so that would flip it. The second one, I'd have to multiply, or one idea would be to multiply by -4. Multiplying by a negative does the same thing as what we just saw when we divided by a negative. Okay, so let's look at an example. We've got -5x is less than or equal to 20. So what I want to do here is I want to divide by -5 on both sides. But because I divided by -5, that whole thing goes away. Because I divided by -5, I'm going to flip my inequality around so that it is greater than or equal to instead of less than or equal to. And then 20 divided by -5 is -4. And remember, we can always go back and think about this. If I plug in a number that's greater than or equal to -4, like 0, is that what works here? -5 times 0 is less than or equal to 20. Okay? So we can kind of verify and prove to ourselves that, yeah, this makes sense that it flips the inequality around. And the reason it's flipping the inequality around, it's just basically our interaction of negatives happening. Because we're multiplying or dividing by a negative, we know it's going to switch the sign of what's on the other side. And so that's what's kind of making us have to also flip the inequality. It's kind of weird. I'm going to be honest. It's kind of weird. Let's look at B. To solve this, I'd divide both sides by 7. Now, this example is to show us a distinction we need to make. Did we divide by a negative number when we divided by 7? No. We are dividing by +7. So our inequality does not flip. We're going to figure this out. -14 divided by 7 is -2. But because what we divided by was positive, it doesn't flip the inequality. That's an easy mistake to make, is to think that just because there's a negative involved at all, that we flip it. But it's a very specific situation when we divide by a negative. So the bottom of this needs to be negative in order for us to apply this rule. So I'm going to put an open circle at -2. That's such a large open circle. I feel like that's terrible. I'm so sorry. And then we shade to the right. Okay. Now C up here brings in this idea of our variables on the right. We can still solve it by dividing both sides by 8. And that gives us 4 is less than or equal to y. You can leave your answer like that, or we can use that symmetric property of equality to flip it around. Just make sure you also flip the inequality symbol. Whichever way is easier for you to think about this. Like for some of you, you might be thinking 4 is less than or equal to y. I can easily graph that and not mess it up. But I think most of us at this point in Algebra 1 would be better off switching it around. So put in a filled-in circle, and then graph to the right. All right, this last one, D. I have -n is greater than or equal to 6. So the idea here is n is almost by itself, but has a negative. So you can think of how to do this in a couple different ways. I think of this usually like I'm dividing by a -1, because that's going to switch the sign. You could also think about it like you're multiplying by -1. You could also just think, oh, well, I know that if it's -n and 6, I need to make it +n and -6. But we do need to make sure we realize, okay, it flips the inequality, because what I'm actually doing when I move that negative across is making it to where the opposite of what we started with is true. So n is less than or equal to -6. So filled-in circle at -6, and then graph to the left. Thanks for watching. Please feel free to subscribe, like, comment, all that normal awesome stuff, and I'll see you in the next video where we expand on this idea of solving inequalities. Thanks.